electromagnetic spectrum. It is a electromagnetic spectrum, and it is absorbed and reflecting the radiation in practice forever. The spectral reflectance definitely it should be influenced by the reflectivity of characteristics and other factors like atmospheric transmissibility. These are all playing the important role. And the spectrum contains many bands and wavelengths of which visible and infrared spectra, which are used for conventional photographic reproduction in aerial and space photography. This technique has certain advantages like a comprehensive, instantaneous synoptic view of large areas and the repetitive observations we see. Your next one it is a photogeological study. In photogeology, it is an ideal tool for exploration, where geomorphological features have an influence on a mineral occurrence and concentration. This technique was successfully used in locating a particular bauxite-bearing laterite in the capital east coast of India. Maps were made by the photogeological methods, and which are the must be accompanied by the selective and detailed field checks. Yes, definitely the air photos are taken by cameras and mounted on aeroplanes. The terrain it is photographed in the continuous and lateral overlaps, so that the stereo photos models of that area can be seen when a set of overlapping photographs are placed under the stereoscope. So that uh, definitely we say those photographs are playing the very important role to recognize of different minerals. Again, airborne geophysical methods. This principle it is also similar for a ground geophysical methods, and we see that some ground exploration methods we see. In a ground exploration methods are most important in to delineate the physical properties and chemical nature of individual deposits consisting of a two operation zones. Yeah, detailed ground definitions of a target and three-dimensional sampling we should collect, and those are given below. The first one we see the detailed ground definition or targets. Yeah, it's related to the regional geological mapping, and it's carried out for delineating the potential mineral bearing areas. That's a 1:25, 1:50,000 scale, up to when come into the small scale, that is 1:25,000 scale. These are usually available with Geological Survey of India. If it is a totally virgin area, the exploration agency has to prepare the geological map. The geological map consists the most important ingredient for exploration. Geochemical sampling and mapping. Yeah, once if you finish that collecting of the samples from different areas, and then geochemically how we will follow. The first one it is geologically we will collect the samples, and second one it is geochemically the sampling and the mapping, the quantitative determination of anomalous distribution of certain elements in surface and subsurface forward. And when we compare with known background values, it's a given an idea of the rock mineral deposits hidden below the ground. Yes, definitely whatever mineral deposits or whatever mineral deposits which are found below the ground, and these ground subsurface it's related to subsurface areas, and whether it's coming towards the surface in the form of a weathered zone, and then we'll collect samples and we'll do the analysis and we'll do the mapping. So either maybe it's from rock samples or stream sediment samples, soil samples, or whatever, water samples also. As per grids, grid lines, we collect the sample. And so once we collect the sample from that areas, from the different locations of that areas, the rapid geochemical analysis is followed. Geochemical methods are playing very important role, and it's giving the very accuracy results, and it's giving the clear information about the target areas. So, where we'll collect the soil sample? We see that. If the first one is the soil sample, the residual soils in a temperature and tropical regions are carry mineral particles of parent earth. So, soil geochemical sampling aims to recognize such values and anomalous stones and anomaly points, and which are having the high value concentrations in a soil capping areas. A stream sediment sampling. The most and widely used technique chemical surveys. It's a fine stream sediments which are collected from active stream channels for floodplains, so in floodplains, and from the floodplains we carry the mineral in a fine form and derived from their original source of error. The water sampling. The water sampling is extremely useful in the reconnaissance surveys for the identification of target areas, in particular uranium exploration and in zinc and copper. Water samples are collected from lakes, rivers, from underground sources. And next, coming into the rock sample. In a rock samples, we will collect the samples from the fresh outcrops, where we are cutting the chips and pre-determined from the grid points. Yeah, one more term here we will use, that's the indicator or pathfinder elements. In particular, when you come into the geophysical surveys, an element which are measured in order to detect where we detect an ore body, it's a streams, it is an indicator element. In majority of the cases, the indicator element is an economically valuable component of that ore, being the sort of, for example, copper for copper ore deposits or uranium for uranium ores. And when we go to the pathfinder, means here the one element it is giving the information about another element. And just example for here, if you see the arsenic, it is a good indicator, a good pathfinder for a gold deposit. And uh, this arsenic, it is called as a pathfinder element here. In geochemical prospecting, data can be more effectively and it can be interpreted by the data processing uh, techniques with the help of available software and use of different computers. The methodology in brief, it is based on the following concepts. Any area under the investigation will have three types of geochemical values. Yeah, the one, it is a background value, depending on the background value. And one, it's to describe the average metal value of in the area where it is unmineralized zone. Suppose if you wanted to find out the mineralization zone or threshold values in certain areas. So what to do? Before going to analysis of that area, we have a knowledge. We have a knowledge about the normal background value of that particular element. So what it is the normal background value? The normal background value means normally the element how it was present, whether it is in a mineralized, unmineralized zone. Suppose example for if you see the uranium in a soil. Generally, uranium in a soil, the average value it is 150. So it is where we calculate the unmineralized zone. Suppose if you have collected the samples from different locations and you have analyzed, then you have analyzed, then you will get some more values above the 1 ppm values. Then we can see and we can compare with the normal background values. The normal background values, we know that it is 1 ppm in soils. If it is a more 1 ppm, suppose 10, 15, 20, 30, 40 ppm like that, then we will do again the average and again we see the same values of a normal background value. If it is exceeded that, then we consider that area it is as a mineralization factor. Again, one more word, it is threshold value. The threshold value, it is a describe the zone, it's a separating the average values from anomalous values. Here, we see the anomalous values also. The anomalous values means here above the background values, certain points we fixed above the background values and above the threshold values. So annual average will calculate the annual average values, and the upper limit of background value it is called as a threshold value. And we will apply these threshold value throughout the sampling area where it is recognized as anomalous points. And those anomalous points must and should have the above the threshold, above the normal background values. So such points are called threshold values also. So next one it is geobotanical sampling. In a geobotanical sampling and mapping, here we will particularly will collect the sample of plant species in the mineralization zone. That's maybe the sample maybe it is a bark material or root material, plant leaves or plant stems, and these samples will cut into the small pieces and dried in a sun rays. Then we will convert into the ash with a 450 degrees centigrade, 450 degrees centigrade, and the ash we will send into the laboratory for analysis. So here, the growth of a plant we see, and how the plant it is a growth in certain areas. Suppose the example for we see in alkaline areas particularly. In alkaline areas, we'll see the plants will not grow properly. Or else we see in some other red soil areas, if you can see. The red soil areas are having the good growth of the plants. Then you compare it between the alkaline, particularly alkaline areas of the plants and the red soil areas of the plants. So there is a must and should we find out the variation between the alkaline zone of soil areas plants and the red zone soils of the plants. Because of what is happening there, in alkaline areas particularly, it's absorbing the plants of the alkali metals when compared with the soil. So that is the reason it's showing the impact. And then once we will do the analysis in the same area, then we'll get the alkali metals. And we will do the same sample of plant species in the red soils, we'll get the different figures. So here geologically, the variations we can see here. The growth and the distribution, it's different, and it's influenced by the subsurface of the geological technique. So that the geobotanical surveys which are involves visual study for the nature and the distribution of the vegetative cover, the plant distribution, the presence of indicator plants, mutational or morphological changes in the species introduced by the mineral enrichment, etc. etc. Then coming to the geophysical methods. In geophysical prospecting, it is a search for hidden mineral deposits by measuring of certain physical properties of Earth's surface. Those properties we likely we see with the using of gravity, magnetism, seismicity, activity of different rocks. And these are all we will apply and we can interpret with available of geological data. There are 5 major methods are available. One is gravity, second one is magnetic, third one is electrical, fourth one is seismic, and the fifth one is a radiometric method. In a gravity method, you see the gravity method. The principal sphere, the principles of gravity method, where is the anomalous are located? With the gravity of the place to place, it may be different, and the area is also we have to search. The heavy mass may be massive sulfide ores, either ore, body of a chromite, etc. and etc. From all these causes and the deflections, it is indicating the gravitational influence. The instrument it is used to measure the deflections, maybe we are using there the pendulum, torsion balance, and the gravimeter. In magnetic method, certain rocks have magnetic properties. They exert their magnetic influence above the normal magnetic field of the Earth. Minerals like magnetite, pyrrhotite exert magnetic influence causing the deflection, and the magnetic needle. So depend on their properties of magnetic minerals. And the needle, if it is moving and it's giving the fluctuation readings in that one. The sensitive instruments like magnetometer, which are used to detect these minerals, whether the area it has magnetic minerals or not. Electrical methods. These electrical methods are relevant in survey for metallic mineral deposits. Some make use of conductivity and self-potential, and while others make use of inductive response properties of rocks. Some other based on measurement or of resistivity of rocks. In it is seismic method. We will find out the capacity of the rocks and which are transmit the earthquake waves. We will study the seismic wave studies. The artificial earthquakes which are produced the explosion and the sensitive seismographs which are measured the waves, the reflection and the reflection waves of the studies we see in this method. Yeah. All these methods except seismic are capable of being executed the airborne instruments to cover a large areas rapidly we see. Yeah, radiometric, coming to the next one, it's a radiometric method. In a radiometric method, we will study the radioactive minerals like uranium, thorium, lead, and those. These are all we can easily detect and estimated by the help of radiometric method. When you go into the portable Geiger-Müller counters, radiation survey meters are used for the type of exploration. This is applicable in particularly only radioactive minerals deposits. Just wait, please. Wait. Yeah. Yeah. Yeah, coming to the geochemistry point of view, it's a geochemistry. It is a refers to determination of the absolute abundance of elements in Earth. Geochemistry can apply in the mineral exploration. So mainly, it's concerned with the preparation and interpretation of geochemical maps and investigation of the basic principles we need. So, geochemical prospecting can be realized only through the understanding the principles that govern and distribution of elements in the earth. Geochemically and geologically, the earth is a dynamic system in which the materials move from one place to the another and change into the composition by variety of a geological process, the melting, the crystallization, the erosion, yeah, dissolution, and the precipitation. Based on the differential of pressure, temperature, and the chemistry, the geochemical environment of the Earth, it can be broadly classified into the deep-seated environment and the superficial environment. Yeah, the deep-seated environment, what it is a deep-seated environment? The deep-seated environment, it is also called as a primary environment. So what is happening? What is happen in a primary environment? Yeah, in the primary environment, the magma it's coming from the very deeper level from the subsurface, so that the elements which are reached to the surface and it's bringing towards the surface and dispersed on the surface. So the deep-seated environment it's extends to downwards from the lower levels and circulating the meteoric water, and it's consisting of a deepest level and at which a normal rocks can be formed. It is an environment high of high temperature and the pressure, restrict circulation of fluids and the private. It's having the low and the free oxygen content here. So that this environment it has high temperature and the pressure. This environment it has a high temperature and the pressure, and it's the circulation of a fluid material also it's within the limit, and it's related to the low free oxygen content. So that we will consider that area it is as a deep seated environment, or it is called as a primary environment. When coming to the superficial environment, it's characterized by the process of weathering, erosion, and sedimentation at the surface of the earth. Here, what is happening when after crystallization of magma on the surface, and it is uh, and it is after some times the same outcrops which are face the weathering and which are participated in the erosion process and the sedimentation it is going to be started. So this segmentation in the segmentation process, the pre-existent rocks which are cut down into the small pieces and disintegrated from the same rock sources, and then they will transport to the one place to the another place, and they will settle down in a low lying areas, or they will settle down, or they will form in a low depression areas layer by layer. So here the sediments which are formed as a layer by layer under the uh, surface. So slowly it is formed as a superficial environment. And it is characterized by low temperatures and nearly constant low pressure. The free movement of solutions will be moving, and abundance of free oxygen and water and CO2. Plenty of oxygen and plenty of water molecules and plenty of CO2, and solutions will participate in that one. The movement of earth materials from one environment to the another environment, it can be conveniently visualized in the terms of a closed cycle. It is referred as a geochemical cycle. Yeah, this is a geochemical cycle. In a geochemical cycle, actually, you see here in the bottom, the primary material it will come from this one. It's a magma, and when it is bleached to the surface, and it's crystallizing, the process of a crystallization. Then, in your first step, it is forming as a igneous rocks, and from this magma, various forms of water molecules and gases will release to outside, and these gases will form as an atmosphere or it will be reached to the atmosphere. And the same in the crystallization process, it is releasing the huge amount of the water molecules on the surface, and it's formed as a hydrosphere. And then these igneous rocks, in the presence of the temperature and the pressure, the re-melting of igneous rocks, which again they will come back and form as a magma. This is one step. And then from this igneous rocks again, it is going to be formed as a are participating in weathering and transporting process, and it's disintegrating into small pieces. They will be formed. They will be formed as sediments, and these sediments will form the participate in the agency process, and they will be formed as a sedimentary rocks. This is second stage. Yeah, one again, coming to the next biogenic deposits also, there may be chance here the farms. They will starting again from the crystallization stage, from this one atmosphere, different atmosphere having the different gases, and at hydrosphere it's having the water molecules, and both will be joined in a biosphere. Biosphere it's related to the plant and elements which are living on the sphere, and those will be released the different material on the surface, and it leads to formation as a biogenic deposits, and those will be also participated into the biogenic process, and the small rock will be cutting it down into the small sediments, and they will form as sedimentary rocks here. So these sedimentary rocks, again, in the presence of a huge amount of temperature and pressure, and they will be changed as a metamorphic rocks. The process it is called as a metamorphism, and metamorphic rocks will be formed here. So here, when they are going to be formed from starting stage onwards, in the recrystallization, which are getting the huge amount of magma material, it's coming from the very deeper level onwards. It's bringing the huge amount of metals. It may be trace elements, and those elements which are the trace elements, minor elements, major, and including the rare elements also. So these rock will be settled down on the surface, and again they will participate in the cycle, geochemical cycle. The elements which are distributed and formed and reformed and recrystallized in different formations. So in the geochemical cycle, we have seen that's right side of this diagram. It's moving the clockwise direction. Yes, it's a sedimentary rocks progressively. It's by the metamorphosed as they are subjected to the increasing temperature, pressure, and increment of new materials from from outside the system. So the sedimentary rocks which are progressively metamorphosed as they are subjected to increasing the temperature, pressure, and increment of new materials from outside the system. They may eventually attain a state of a fluidity such that under recrystallization, they can differentiate to various kinds of igneous rocks and the hydrothermal extractions we also see. When aeration brings the resulting suit of rocks into the superficial environment, again, the component elements are relatively its solubility in water, redistributed by the weathering agencies, primarily in accordance with the a new series a new series of sedimentary rocks is then deposited and the cycle it is closed. The geochemical cycle therefore includes the deep-seated environment and their process and the metamorphism and igneous differentiation and the superficial process of weathering, erosion, transportation, and sedimentation. All these processes will be involved in that one discussion. Material on the earth, it's constantly subjected to transformation as a process through the different environment in the geochemical cycle. This process in which atoms and particles which are moved to new locations and the geochemical environment is referred as a geochemical dispersion. Yes, any material, if you can see that, it's subjected to the means, it's a constantly, it has a transformation as a process through the different environment and the geochemical cycle. This process in which the atoms, those atoms and the other particles which move from one place to another place. It's again the relation of the geochemical environment. It is referred as a to geochemical dispersion. Yeah, geochemical dispersion may occur by mechanical process. Yes, definitely it is a mechanical process and even chemical and biological factors also. Mobility it is occurred, but dispersion it's a must and should be related to mechanical process and the chemical and biological factors also. Yeah, here this picture it is showing the mobility of a material from one place to another place, and it's yeah the response of an element whether it is going to be dispersion and it's a depend on the its mobility and that is how it is easily can dispersed and what is the relative to the other associated material. So as per that, the material it is going to be dispersed or moved from one place to the another place, and the mobility it is depend on the chemical impact or chemical factors or chemically how it was formed, and as per that, those elements which are moved from one place to the another place. Yeah. Yeah, the distribution of elements of a constituents, rocks and material minerals in the response to the various geological process. The term it is referred as a geochemical mobility. Distribution of elements and it's consisting of a different rock and minerals and the response of various geological process. The term we are calling as a geochemical mobility. Yeah. In a geochemical mobility, fundamentally the responses of element, it's a dispersion process. It is governed by the mobility, and that is AC, which it is may move in an any given environment. The mobility is depend on the mechanical properties of the mobile phase and factors such as the viscosity of magma and the solutions and size, shape, the density of plastic grains, and the following of a scheme of the water. The relation between the mobility and the chemical differentiation and the other hand, it's rather than the more involved. Here, the prime factors are changes in the relative stability of the various coexisting fluid and the crystallines mobile phases that result from changes into the environmental condition. In crystallization of magmas, mobility under the high temperature and pressure conditions, how it will be mobile, and that's called as hypogean mobility. In a crystallization of magmas, the constituents that cannot be accommodated in the lattice structure of stable rock, forming minerals are concentrated in mobile residual fluid. The water which cannot be entirely accommodated in the minerals of the igneous rock, the progressively which are enriched in the residual plates. Suppose in a hydrothermal vein deposits, maybe which are participated and precipitated at the stage of a primary geochemical cycle. At high temperature and the pressure, hydrogen minerals are sedimentary rocks, becomes which are unstable, and water it's released to become a principal constant in a mobile phase. So it's a supergene elements which siliceous sulfide free environment. It's a relative mobility. And the major elements and minor elements how they are having the mobility capable. We see in a very mobile in major elements, those we see the sulfur and the chlorine, and minor elements like bromine, iodine, molybdenum, boron, and selenium. Moderately mobile elements are major elements like potassium, calcium, magnesium, sodium, and minor elements like zinc, barium, and uranium. Moderately immobile, the silicon, manganese, and very minor elements like nickel, cobalt, copper, arsenic, lead. Very immobile, iron, alumina, titanium, and minor elements like chromium, rare earth elements. And some association of elements also be in geochemical survey and elements measured to detect and ore body, it is referred to as an indicator elements. In many situations, the indicator elements is the same element as the ore deposits. Example, element, the gold for gold deposits. And if it is a ore mineral or ore element too difficult to analyze, then another element which is associated with the ore, it will be useful and it is called as a pathfinder. Example, best example for that one, arsenic, it is for gold. Yeah, the pathfinder elements material are sampled, toe type. Arsenic, it is, we see the material sampled, suppose if you collect the wall rock or residual side, we may it is to find out the vein type deposits of the aram deposits. And again, hydroxyuram, so wall rock and soils, and it's find out it's reached to find out the complex of zinc, lead, and argentinum ores. And selenium, we to see the selenium goes on residual soils and epigenetic sulfides, and argentinum residual soil, and reached to find out the argentinum bearing aram deposits and sulfates. So we collect the water samples, and more we'll get the sulfide deposits. And finally, the movement of the earth material from one environment to another, it can be explained by the geochemical cycle C. And geochemical exploration, so mainly it's governed by the mobility of elements, and the geochemical cycle and geochemical environments help to understand the mobility of elements. Yeah. That all what we have seen. And then, yeah, geochemical normal background values also we have discussed. Geochemical anomaly also discussed. Yeah, here there are various sampling media we will collect in for a geochemical exploration point of view. The quantitative the determination of the anomalous distribution of certain elements in the surface soil and subsurface overburden, and comparison with a known background value give an idea of mineral deposits hidden below the ground. Yeah, it is an essential principle for a geochemical prospective. The common practice followed in geochemical method is collection of a soil, stream sediment, water, rock samples at regular intervals. The grid lines being the transfers to the strikers of suspected zone mineralization. Yes, for that purpose, we collectively samples from the soils. The residual soils are playing a very important role, and which are having the temperature in tropical regions to carry the different mineral particles from the parent rock. Soil geochemical sampling aims to recognize the such values, anomaly, high value concentrations, indicating the soil sample capable targeting areas. Stream sediment sampling, it's a most widely used technique in geochemical surveys. The fine stream sediments collected from active stream channels or the floodplains. Floodplains carry the mineral matters in fine form derived from their organic source of a rock. Yeah, water samples also will collect, and water samples also playing a very important role in the particular study about in little values of uranium and zinc and copper. Yeah, rock sampling. Its rock samples are collected from visible rock outcrops by cutting the chips of the rocks from the predetermined grid patterns. Okay, now I'm stopping here. We'll continue tomorrow. Thank you.